All right, so we're going to continue here. I'm looking at exponent rules. Specifically, um, in this first section, we're going to talk about what we're going to call the product rule and power rules. And so there's going to be three of those. When we get finished with all of our exponent rules through section 5.2, we're going to end up having 9 rules that we'll talk about. And so I'm going to sort of simplify some of that for you as we go. I think it'll help you to have it kind of simplified together. So just be aware of that. In this first section, though, we need to start with a very basic rule. It's a very common rule that we use called the product rule. And so what the product rule says, and what I would suggest to you as you're watching this, is make sure that somewhere written down in your notes, you write the name of the rule, because I'm going to give you that. Write down this general form, but as I explain this to you, I'm also going to give you sort of a layman's term of what it means from that exponent rule. Okay, so it would be important. It's a good thing about having a video. You can rewind it and have me, hear me say it multiple times. And so I would make sure I have all that written down, because understanding the layman's term or phrase is going to definitely help you here. So what the product rule says is that if we have two things that we're multiplying together that have the same base, okay, again, in the first video we talked about what the base was. And so we have the same base. If we are multiplying and we have the same base, we're going to keep that base and add our exponents. So, as an example, I'll use this first one, and I'm going to write out more detail than is actually needed here, just because I want you to see what's happening. If you were to take 8 to the second power times 8 to the fifth power and literally write out what that means. Well, 8 to the second power, or 8 squared, means 8 times 8. And 8 to the fifth power means 8 times 8 times 8 times 8 times 8. Don't need the last multiplication symbol. Now, if you'll notice, that's just a bunch of 8s being multiplied. And so you could rewrite that as one expression, one exponential expression that says that it is 8 to the 1, 2, 3, 4, 5, 6, 7th power. And so somebody long before us realized that, well, if I'm multiplying and I have the same base, then all that's happening are all of these 8s are getting multiplied. So I can just put them all together and add that exponent. And so the 2 plus the 5 gives us the 7. So we keep our base of 8 and simply add the exponents. Now, notice here we do not multiply 8 times 8. This is not 64 to the 7th power. It is 8 to the 7th power. Okay, so be careful here, because I see a lot of people that want to try to multiply because they see the multiplication symbol and they think, oh, I need to put those 8s together. No, 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 no. If we have the same base and we're multiplying, you keep the base. Don't change it. Keep it as 8 and add exponents. So we should be able to roll through these next few examples pretty quickly then. So we have negative 7 to the fifth power times negative 7 cubed. Well, again, our base here is negative 7, and we are going to keep it in parentheses. And then we're going to add exponents. 5 plus 3 is 8. And I'm not going to ask you to simplify that and tell me that number. Okay, right now I just want us to focus on what does the rule say, how is that going to work. So, we look at the next one. I always ask, what is this one going to be? And most people can tell me it's y to the fourth. And my question becomes, well, why is it to the fourth power? And the answer to that is because this y that's by itself is to the first power. It's understood 1. So you're keeping the y, you're adding the 3 and the 1, and you get the fourth power. And so what about the next one? We do have the same base, so we're going to keep the base, and we're going to add those exponents. So 2 plus 5 plus 6 is going to be, it's going to be 13. And then what about the next one? So I always ask in class, tell me what this one is. And I always have a lot of answers. I have 6 to the 6th, and I have 12 to the 6th, and I have all these different things. And actually, none of those are correct because the product rule, what does the word product mean? It means multiply, right? Well, in this case, we are adding. So the product rule does not apply. Now, could we simplify that? Could we find the value of this? Sure. If you write out literally what it means, 6 to the 4th is 6 times 6 times 6 times 6, and then 6 squared is 6 times 6. And we could do each of those multiplications and we could add those together. But our order of operations says that we've got to multiply before we can add. So we cannot just put them all together. You've got to do 6 to the 4th, you've got to do 6 squared, and then you could add those. And so for our process of using the product rule, we're going to say the product rule does not apply. So I'm going to say DNA for does not apply. Now, if the product rule does apply and it works, then it's pretty simple. You just simply keep the base, add the exponents. So let's look at a couple other examples here. So again, if you take, again, I'll write this out in a little more detail than probably needed. If you take this first example and you again think about literally what it means, well, it's 5 times m, because again, our base is m. The 5 is not part of the base. And it's being multiplied by 2 times m times m times m times m times m times m. Because again, m is the base in that second part as well. And so really we have this 5, this 2, and then a bunch of m's being multiplied. And you know from back early in this class that we can rearrange the way we multiply stuff, right? So we can actually multiply the 5 times 2 and get 10. And then all of our m's we can put together. That's where the product rule is going to come in. 2 plus 6 of those is going to be 8 of those m's. And so we end up with 10m to the 8th. So there's our simplified expression. Now, look at the next one. What's that going to give us? Again, we can multiply 3 times 9, which is 27. And then our p to the 5th times p to the 4th, keep our base of p, add those exponents, and we get p to the 9th. And then if you want to pause the video for a second and do the next one on your own, that'd be great. When you do that, you should end up with negative 21 p to the 13th. So again, multiplying the negative 7 times 3, and then p to the 5th times p to the 8th, keep our base and add the 8 and 5. If you have any questions about the product rule, please let me know. So our next rule is what we call the power rules. Now there's 3 of these power rules, so we're going to call them power rules A, B, and C. So power rule A, we're going to refer to as a power to a power, meaning you have a base that's raised to an exponent, and then that's being raised to another exponent. Okay, so a power raised to another power. And what this rule says is that if that happens, you're going to keep your base, but you're going to multiply your exponents. Okay, so let me give you an example. If I ask you to find 2 cubed squared. Well, if you think about literally what does that mean, well, 2 cubed is 2 times 2 times 2. But then you're squaring that, and so you're doing it twice, and so 2 times 2 times 2 times 2 times 2 times 2 would give us all of those 2's multiplied out. Well, again, how many is that? Well, it's just 6, right? And so, again, somebody long before us realized that if I take some base and raise it to a power, and then I raise that to another power, I'm doing that base the number of times of the second power, and so I can just multiply those and get 3 times 2 in this case and get to the sixth. And so this rule is the only time that you're ever going to multiply exponents. And so when it's a power raised to another power, we'll multiply. So quickly, let's look at these examples. Again, not worrying about simplifying these to whatever the number is until I ask you to evaluate. I'm not really worried about you getting that final number. Okay, so just want to make sure we know how to use this rule. So on the first one, 4 squared cubed. Well, according to this rule, we're going to keep our base of 4. We're going to multiply those exponents, 2 times 3, and get 6. Again, we could simplify that out if we needed to. On the next one, 5 cubed to the 4th power. Well, again, that's 5 3 times, and that 3 times is done 4 times. And so 3 times 4 is where that's going to come from. So it's 5 to the 12th power. And again, be careful not to try to add your exponents. We're not adding those here. We're multiplying because it's a power to a power. What about the next one? We're going to have 6 to the 10th power. And then on the last one, we have a to the 8th power. Again, that power to a power, we're just going to multiply the exponents. So, power rule B is going to work like a distributive property. Now, it is not the distributive property, but it sort of works like that. Because what it says is that if we have this expression inside parentheses being raised to a power, this power applies to everything on the inside. It applies to the A and it applies to the B. And so it's sort of this idea of giving that power to everything, sort of like the distributive property works, but it is not the distributive property. So for example, if I gave you 3xy squared, again, literally if you write out what it means, well, it's 3xy times 3xy. And so when you get ready to multiply that, how many 3's do you have being multiplied? Well, you have 2 of them. And how many x's do you have? Well, there's 2 of those. And how many y's do you have? There's 2 of those. And so when you do simplify, you can do this 3 squared and get 9. I'm not really worried about that at this moment. That would be our final answer. But what I want you to see is that we just basically gave this power of 2 to the 3 in this step. Gave it to the 3, we gave it to the x, we gave it to the y. And so everything is getting the power of 2, including the number. Sometimes I'll see people that will give the power to the variables, but they don't ever give it to the number. And so that messes everything up. So you do have to give that power to everything inside the parentheses. So with that in mind, look at this next one here. We've got 2ab raised to the 4th power. So according to this rule, we're going to give the power of 4 to the 2. We're going to give the power of 4 to the a, and we're going to give it to the b. And yeah, we'll go ahead and simplify. If our numbers are fairly small, which they are in this case, then we will go ahead and simplify that. So 2 to the 4th power is 16. And then it's a to the 4th, b to the 4th. And so there would be our final answer. Now, look at the next one. What gets the power here? Hopefully you say m and n. And my question would be, well, why not the 5? And hopefully you say, well, it's not in parentheses. It's not part of the base. It's not getting the power. And that's exactly right. So that 5 is just going to stay 5. And then m is going to get the 3rd power, and n gets the 3rd power. And then there's nothing else you can do with that. It is simplified. And so there's our answer. Now, look at this last one, because it is a little bit different. On this one, we have this power of 5 that goes to everything. So 3 is going to get the 5th power. A squared is going to get the 5th power. We'll talk about that in a second. b to the fourth is going to get the fifth power also. Now, you'll notice that when we give that power of 5, the a squared and b to the fourth both get the power. And so it's that base of a raised to the second power raised to the fifth power. And so that is our power to a power rule A that we talked about just a minute ago. And so as we simplify this, 3 to the fifth, we've mentioned already in this class or in a video that it's 243. And then now this A is going to be to the 10th power, and B is going to be to the 20th power because we're multiplying those exponents. And so what you're going to start seeing is that some of these exponent rules will be combined with some of the others. And so you can imagine as we get 9 different rules that we can use, we're going to need a way to really sort of simplify that and make it easy for you. And so I'll give you that coming up soon, because I think it can be really confusing if you if you have to remember, okay, I use this rule and then I use this rule and then I do that rule. And so I want you to see they're going to start being combined, but we'll simplify that for you. Okay, so don't stress out about that too much. Again, if you have any questions about power rule A or B, make sure you let me know. Our last power rule is what we call power rule C. And so this one works like the distributive property too, but it works across a fraction. And so what it says is that if you have this fraction raised to a power, that power applies to everything on the top and everything on the bottom. Okay, so it's going to all of that stuff, which should make some sense. If I were to give you, for example, 1/2 to the 4th power, well, if you literally write out what it means, it's 1/2 times 1/2 times 1/2 times 1/2. And then if you multiply straight across, 1 times 1 times 1 times 1 is 1 to the 4th power. And 2 times 2 times 2 times 2 is 2 to the 4th power. And so really all we did is we gave this power to the 1 and we gave it to the 2. And so there we are. And then we can simplify that. So 1 times 1 times 1 times 1 is 1. I had somebody a couple semesters ago say 4, and no, that's not right. But 1 times 1 times 1 times 1 is 1. And then on the bottom, 2 times 2 times 2 times 2 is 16. And so you would end up with 1 over 16. Okay? So, again, this power rule allows us to just give that power to top and bottom. And so in this first example, 5/3 squared, well, that's 5 squared over 3 squared. And we can simplify that. We know that's 25 over 9. Hopefully not a huge problem. Now, go to the bottom one. By the way, the 25 over 9 does not simplify. If this original fraction does not simplify, then that answer is not going to simplify either. So just kind of a little tidbit, is because some of these numbers could get big. So on the next one, we have 5/2 to the 4th power. And so that's the same thing as 5 to the 4th power over 2 to the 4th power. And 5 to the 4th power is 625. And 2 to the 4th power is 16. Again, that doesn't simplify. Now, somebody asks, well, how do I know if I need to simplify that number and tell what it is versus just leaving it with the exponent? Well, number one, a lot of times I'll tell you, evaluate, so give me the number, or I may just say, leave it in exponential form. Our basic rule that we try to stick by is if the power is 6 or less, and usually strictly just less than 6, then we'll just tell that it's whatever number. So for example, 5 to the 4th power, that's 625. We'll typically try to tell that number. Also, if that number ends up being less than 1,000, we typically tell the number. So for example, 2 to the 6th power is 2 times 2 times 2 times 2, and so on. Well, that's not going to be over 1,000. And so we may tell that number. But as you get into, for example, 5 to the 6th power. Well, that's way over 1,000, so we're just going to leave that. We would leave that as 5 to the 6th. And so that's kind of our general rule. That's not strict or anything, but that's typically what we try to go by. So just kind of know that as we're moving forward. Now, look at the next one. We have 1 over x to the 10th power. So again, using this power rule, it says we're going to take 1 to the 10th divided by x to the 10th. And we can simplify that because 1 to the 10th is just 1 over x to the 10th. And so there is our final answer. And then on the last one, we have 1/3 to the 5th. And so, again, that's 1 to the 5th divided by 3 to the 5th. And 1 to the 5th is 1. 3 to the 5th, again, is 243. So you've now seen that 3 to the 5th, I think, 3 different times in the last